Look at this crowd. Thanks for coming. This is super exciting. Also nervous, all kinds of emotions. Super proud just at the scale of this crowd and this event in general. We've never done this before, and I'm looking forward to doing this every year. So I appreciate you all flying from all around the world and country to come see us. Yeah, I'm going to talk about yesterday, not literally yesterday, but maybe the past 10 years, give you an idea of where we came from, and hope it gives you some perspective of the speed, the level of change that we've created, and helps you give a set a course and a direction for where we're going. I'll give you an update on where we're at today. Many of you probably have a decent idea of what kind of product we're putting out today, what our features and benefits are, but I'll make sure I cover them, and you'll learn more from the factory rotation as well. And then I'll talk a little bit about what's coming next. A little harder to illustrate the future. It's something I've learned throughout this process of preparing for this. It's easy to show pictures of the past and comment on them, but it's a much more difficult thing to illustrate the future. I do a lot of it on my whiteboard, but that's not adequate enough for a presentation. So I'll speak on it, and if you have any questions at any time during the presentation or after, please come see me. I love talking about the product. Kurt's very accurate. I don't know about the Taylor Swift reference. I don't watch football. I do like Taylor Swift, but I am slightly obsessed with the product and what we build. So anybody who's curious, please come talk to me. So we'll start with yesterday, as in 2012. So in 2012, at the beginning of 2012, it was just me by myself. I was the first employee of a company called Mass HVAC. Many of you probably have never heard of Mass HVAC. Some of you definitely have, and maybe work with them every day. They've got a crew of at least 4 here. I encourage you to meet them. Super talented, smart people. At this time, what we were doing was modifying Daikin air handlers to create very powerful solutions, basically custom air handlers by using and leveraging their air handling product. In 2012, the name Q-PAC came about as a brand. So at this time, I believe, to my knowledge, I don't know, I was 23, 24. So it felt as if we were the only ones thinking this way. So we had met with Zielabeg, Rosenberg. I'm not sure about EBM, maybe EBM. And we were wondering why this technology had not made it to commercial air handlers. It didn't make sense. It seemed too good to be true. So being small, being nimble, that's an advantage. 1 person, 2 people operation, you can do whatever you want. So we started to apply these right away. That's actually the literal first logo. That's not a joke. It's kind of funny to look at. But yeah, we were a brand within Mass, and we were in Green Cove Springs, which is just across the St. Johns River. So it's about 35-minute drive from where we are right now. So we didn't move very far. We were in a World War II hangar, from the 1940s, 1930s. And it's exactly what you'd expect of a World War II hangar. Very decrepit, falling apart, massive, massive doors that we use as our ventilation. But it was where you would want to start up, so we had about 3,000 square feet, I think, like at the very beginning. We were sharing it. We were very fortunate that the owner of another manufacturing company allowed us to get our start there. And that 3,000 square feet project, one project at a time, ended up taking over half their factory. And at some point, they really politely asked us, you should probably find another place to keep growing. And a couple hurricanes, we had to move out to portable trailers, which honestly, I found out that portable construction trailers are awesome. Like for offices, I love it. We like that better than our offices in the hangar. So at this time, it was really raw. It was literally just fans and a wall. Like the very beginning, it was just, we were building air handlers. So we were splitting air streams with foam injected panels and, that actually need an R value so that you have insulation. And we were like, wow, these things are stiff. These are strong. We can build a wall. It doesn't matter that it's insulated. So we just used our suppliers and built our original bulkhead that holds our fans, the EC fans, out of a foam wall. And at this time, to be clear too, we weren't really doing much manufacturing. We were doing mostly applications. We were application engineers, and we were leaning on other suppliers and partners to help us build the product. So we did that for a couple of years, just fans and walls. And it was kind of interesting. You have some people that loved it, and then you have some people that didn't understand it and didn't want it at all. So to try to figure that out. But we did learn that it might help if we made it easy on the electrical contractor and the electrical engineers and gave them a single point of power. So something really simple. We just worked with a 508A panel manufacturer. This one is a very interesting photo, very rare because it's got the original Q-PAC logo, which didn't last long. So But it's just all we did was wire back. We installed them on the air handlers and we wired all the EC fans back to one location, like you see today pretty regularly. But this picture is from over 8 years ago, I believe. So at that time, it was pretty early. That got really popular when we created the single point nature to it. It started to really take off. People really valued all the things that the ECM arrays were providing. They were quieter than your traditional fans. They were lighter weight, easier to maintain, basically no maintenance. The inherent redundancy of not having a single point of failure. And also the footprint. When you design air handlers, especially for really cool buildings, right? I've learned over the 12 years, I've really started to appreciate architecture. If there's any architects here, I'd love to meet you because I feel like I should have been an architect because the type of building has probably the largest effect on how the air handlers are shaped. And Mass is absolutely obsessed with cutting out footprint and making units fit in places that you wouldn't expect an air handler to fit. So ECM fan arrays really did it for them. So you can see here's like rows of air handling unit sections with Q-PAC getting installed. Because it's shortened, we could sometimes take 8 feet of length out of an air handler just by using our fan system. So it became really popular. So that gets us from 2012 to 2015, pretty rapid progression. And keep in mind, what we were doing under Mass HVAC was we were building air handlers. That's what we did every day. But then in 2015, we got a really interesting request for a kit. So we had a rep partner who had been buying our solution through our air handlers. And he called and he was like, hey, I got an opportunity. I'd like to use your Q-PAC system, but I don't want it in the air handler. I want it as a kit because I want to replace an old fan. And we had never had that request before. So this is what it looked like. It was called Plaza Corp. Kurt and I will never forget this job. It's permanently tattooed in our memory because we learned a lot. It's in Kansas City, Missouri. I remember it being very hard to find the address. I don't know, Kurt, if you remember that, but these drawings, some of these drawings were actually provided by the engineer who actually came up with the idea. I haven't met him yet, but I really want to meet him because he was really thinking differently. It was a really rather large system. We had never done this many EC fans in an array ever because it's bigger than an air handler that we would normally build. So it really challenged us, but we said, yeah, why not? We'll make it as a kit. So this is about what it would look like. It's just a pallet full of foam injected panels, some sheet metal, some screws, some single point power 508A panels, and some backdraft dampers. Like it really wasn't much. And then obviously there were pallets for the fans. I forgot to show those in here, but there would just be pallets of EC fans. And this was our first kit ever. And I gotta say, I wasn't actually there, but Kurt, he can, tell you how miserable it was. When you have 20 ECM fans on a wall and the electrical contractor's never seen this technology before, and it's all very new and it's really dark and it's tight and there's like no space and everything has to be field wired and you've got like 12 conductors to strip and land in every single motor. I mean, and all the conduit, it's very overwhelming. It costs a ton of time and energy and stress to troubleshoot it. And we learned real quick that we never really want to do this again. That's just the truth. But when we got back from that, with all that challenge and all that chaos and stress, you could see through it. If you thought about it, you're like, there's a huge opportunity here because I didn't show it in those pictures, but it's kind of hard to see. But the door over here on the right picture is tiny. Okay. Like the door is like really small. And there was a huge fan in there. So they cut it out. They literally carried the fan out of that door and they carried our entire system in. And if you forgot all the rest and all the chaos and you only looked at that, it's like, wow, that's pretty awesome. Because if you could do that in a day without any disruption to the air handler or the facility, that could be huge. So that inspired us. And over a couple of years of really thinking about it and testing, we kept shipping kits, not very many at all because, we didn't want to get into it too quickly. But this one really jumped out for me personally. This is probably where where I really started thinking hard about this is we had shipped our first kit to an OEM that actually builds air handlers. So you got to remember, we built air handlers at this time. So it was really interesting to be in an environment that's similar to ours, but it's foreign because they don't really know how the system works and watch them wire it. And I sat there through 3 shifts back to back, didn't go to my hotel, just watching them run the conduit. and the wires. I could not believe the level of just physical work and labor involved in building it. And like at this point, it was like, there's no way that this is going to continue. I don't know if you can see in the back, but this is the end. This is the end of a very large custom commercial air handler. And one of these, the smaller system is a return fan system, and this is the supply. So the supply, the wires are going right through the air handler, and the supply array is actually, this is the supply array. You see all the conduit. All of that is EMT, completely manual bent by craftsmen, like absolute brilliant craftsmen. I'm sure some of you are here in the room that can do this. It's unbelievable. And then this one over here, the return is on the other end of the air handler, as you all know, right? It's up on the top deck. This is a split unit. It's up on the top deck on the other end. So they had to go through, I think, 4 section splits of conduit, and all the joints and everything is just absolutely wild. And that really showed the opportunity. So we got back from that, and we're like, okay, we're going to start testing some kind of junction box. Let's just put a junction box on the wall, and that way, at least you only have to run 1 feet of power and controls. And this is actually one of our first ones. It was 19 ECM fans. And this is where we learned, okay, architecturally, this is really bad because it's a tremendous amount of cables going to one location, which is really hard to manage. And the conductors that were required to wire this were huge. I mean, they were like, the actual copper was like the thickness of my thumb. So it's the competencies required to bend it and to just work with that material was very hard. And that's something that you'll see as a theme over all of Q-PAC's innovation. Is we're very conscious of the types of competencies required to work with us, whether that's design, installation, operation, maintenance. Like, we want to know what type of skill set it requires. As everyone knows, it's, the world's changing. It's more and more difficult to find, craftsmen, tradespeople, like education, and just it's something that we feel is a huge opportunity for us. So anyway, we did some iterations, tested, and we're like, you know what, 9 ECM fans is a pretty good size. It's the horsepowers we're using, when you combine the weight of these EC fans, because we really have a hard limit on the weight too. We don't go over 140 pounds because we want every single thing to be hand carried. When you combine all those factors and you combine like the conduit, we don't go above 1-inch conduit, right? I know it's kind of technical, but if you think about it, once you get beyond a certain size, conductor size and conduit size, you start to really ask the user or the installer to do other things. They have to go find that inventory or change their process. So we wanted to keep it really simple. So we honed in on this 9. So 9 ECM fans per quick connect. I can remember sitting with Kurt, inventing this thing and feeling like it was an absolute prototype. Like, I remember my senior design project is in here, and none of those ever took off or became a thing. And this one, I was like, it felt like a prototype, and I'm pretty sure we sold about $35 million of that prototype without ever changing it, which was absolutely mind-blowing. At this time, the word wiring started to get kind of funny because it was actually wiring before, right? You had to strip wires and do actual wiring like an electrician. It actually became more like assembly. So we started to change our language. Plugging something in and putting a zip tie and zipping a zip tie is not wiring. That's just general assembly. And that goes back to trying to figure out who's qualified to build our product. Around the same time, we realized, hey, it's probably time we create a BACnet solution, right? Most of us in here are familiar with BMS systems, and BACnet has a protocol. So we went out, Kurt and I went out and did a 5-day, I believe, boot camp, and learned how to program Corel controllers. And we came back, and Kurt took the lead, and he built he said he's done a lot of roles. He wasn't kidding. He's done pretty much everything at Q-PAC. He built our entire original control system himself. So that became popular because people were asking for BACnet for years. This is also the same time that we started to get heavily into manufacturing. We started to buy sheet metal equipment because that was kind of the obvious choice to start doing our own metal fabrication. And because we now have our own equipment, we didn't have to use those foam injected panels anymore. We started to get real serious about our wall, which you'll learn a lot about our wall. It's always funny when people say they have sheet metal capabilities and they can build a wall, and I don't think they really understand how much passion and obsession we've put into this design. So I encourage any kind of feedback or things you see that could be improved. Most of the design has actually come from feedback, from contractors visiting and giving us feedback. So that gets to 2018. This is a big year. This is what, if you've heard of Clips, we built our online selection tool. So as all of you probably know, you can't really function in this industry unless you have some way to configure your product in the custom world and commercial HVAC. everything's so unique, it helps to have a tool. So we built our own, and it was interesting because it was more of a sales tool for our air handling side. And as you can see on this picture, like it would spit out things that we can't actually build. So that got kind of tricky. So in 2018, we also moved. I've talked to a few of you about the building. The building, we built the building. Well, I say that we worked with a general contractor and we worked with an engineering firm. And I learned that I'd like to stay in just equipment, like building products, because what you all do in the construction world is wild. It's very hard to manage, and it's definitely not for me. So I was very humbled by the experience, and our building's pretty simple compared to what, the facilities that we're putting our systems in. But it was a lot, and it was cool. But again, we moved in as two separate companies. These pictures are more recent, but you're here. So thank you for coming. We'll give you a great tour. So fan systems as a service. So everything I've told you today or so far, like about the product, it felt like a service. We would have a customer that's in need or had a problem, and we served them. And we did it through fan systems as Q-PAC. This name didn't come about until later, when we realized that it was a service. We've grown through word of mouth, just not a ton of marketing effort, really, just solving problems in a big enough way that people would share, the success stories. And if you have, been exposed to our product directly and seen it for yourself or installed it, please, there's several people here, ask them. So this kind of gives you an illustration of what it takes to build a tailored fan system and have every single harness completely mapped out. The FSAS products, it had a wiring, power circuit, a control circuit, and then you also had to have the tubing because we approximated the airflow using the upstream, the static, or the pressure upstream and the pressure at the cones on the fans. But we started to get our documentation in order. Up at this point, everything was manual in CAD, literally drawing everything. 2019 was a huge year, bittersweet, best friends, literally separating two companies. So up until this point, we were one company, Mass HVAC, and in 2019, Q-PAC spun off as its own corporation, and it was emotional, challenging, but I'm pretty sure every single person totally saw the vision of where both companies were going, and it worked out pretty well. So Mass moved to Minneapolis strategically. I think it's done really good for them. They're doing great. And this is where Q-PAC really started to occupy the entire facility. At this time, like I said before, we were leaning on suppliers and building our 508A panels, and we really stepped into real design here and designed our own Quick Connect. Without the Quick Connects, I don't think we would be here. So I encourage you to check it out, give us your feedback on it. I think it's really transformed us as a company, this concept. Programmers. So in this year, we also invented programmers. So we blended engineers with programmers. We realized that if you want to have a software that's accurate and presenting the right information, it's very iterative process of a designer designing a product and then trying to convey that to someone who knows how to write software. And it can be very painful. And if you look at other companies, it can take 6 months to 12 months to get very minor updates because of this challenge. So we realized most of our engineers had already been exposed to writing software, and whether that's in Excel, writing macros and things like that. So we just decided to lean all the way in, basically. And we basically got all of our engineers set up in an actual development environment, the way that you would see any software developer. And we just started writing code. So today, most of our engineering team can write in C#, and they're actually using a development environment that you would expect of any software developer. So if you design the product on the Q-PAC team, you're also accountable for it in a digital form. So like if you are accountable for the way the wall is shaped and what its structural performance is like, you're also accountable for how it is written in logic. And that allows us to really leverage Quips to the fullest degree. And we can finally have incredibly accurate representations so that anybody here can go on our tool and within a matter of 30 seconds, they have an accurate CAD file that they can drop into their air handler or into their building. And our pace of change can move a lot faster by having our engineers write software. So you'll see a demo later in the rotation. We'll give you a demo of how Quips works. And it spits out some really cool stuff. It's like within seconds, you can download an accurate CAD file and actually pull dimensions from it. This is an interface I thought I'd share. This is kind of what you see behind the scenes if you work here on the engineering team. This is how we test. So if we write new code, and we want to see if we broke some things. We built our own internal graphical interfaces to show, how it's working. So programming or programmers is a huge thing here at Q-PAC, and it's definitely a big differentiator that most people don't know is going on. So in 2020, that was a big year for all of us, right? COVID, I think it was like July, I got a pretty bad phone call where our fan lead times were going from 6 weeks to 36 weeks in one phone call. That's a lot of time to try to figure out how we're going to continue to exist and not have any fan supply. So I remember we called on all hands just to get ideas, and at that time we had built the strongest workforce in our factory that we've ever had in company history. We had hired, I think, like 20 people in 2019, and we weren't about to let them go. So we decided to build a panel shop. So we, at this time, or right before this, we had been working probably 6 years with a partner to build all of our 508A panels. And we felt that with the downtime, there's no better time than right now to invest in building them ourselves. And it's probably one of the most proud things I have to say about all the 12 years I've been doing this. I watched a team within, I want to say, less than 3 months. We stood up an entire 508A panel shop operation and bought all the inventory, did all the circuits ourselves. It was unbelievable. And you'll also get a tour of that as well. But another thing that happened during this time that people don't realize is, we were shipping product and we had to maintain it and support it, obviously. But behind the scenes, all of our engineers were working relentlessly on a complete rebuild of our product. So up until this point, we had accumulated layers and layers of technology, right? It's going from 2012, adding wires, adding controls, adding a touch, a screen interface, adding backnet, and just like layering and layering and layering. And then, you look back and you're like, how did we get here? This is a little bit messy and it could use a redesign. And in 2020, we started the process of completely rebuilding the product from the ground up. And by the end of 2021, instead of it being a service, we called it FS1. We had basically launched our first product. I know that might seem, insignificant, but hopefully a little bit of this history helps you understand that we were a service company, and to become a product company is a little bit different. When you're scaling and you're trying to put out thousands and thousands of kits like we were, it starts to become a little bit more critical that you actually do testing, right? Like in the early days, you sell a project and your customers are kind of your R&D. Today we can't afford to do that. We have to be testing our product. We did not know how to launch products. That's just the truth. I mean, we're being a service is a little bit, it has the freedom to kind of make mistakes during the process. Having a product like this, we've learned a lot, and we're going to continue to learn. But like I said, we rebuilt the product from the ground up. What you're seeing today has had 18 months of just relentless effort from engineers to rebuild, starting over the whole circuit and to simplify it. So I'll go over it real quick. You'll learn a lot today, but we still have our control panel. There's pretty much two options. They all come standard with obviously a disconnect and a fuse disconnect and a handoff auto. I don't know if you guys noticed, but in the previous pictures when we launched our backnet offering originally, we got rid of the handoff auto. I'm not sure why that did happen, but that was a bad idea. So we added the handoff auto back in. The premium option comes with a backnet compatibility, capable controller. Gives you all these things. I won't go through all of them, but you can measure airflow, you can measure the power consumption. It's got all the bells and whistles. The Quick Connect box, I've already covered a lot of it here, but it supports up to 9 fans or 95 amps. It's a single point of connection. Like I said, I don't think we would be here if it wasn't for this device. We try to make it easy to cover. Again, you'll see it. Ergonomics, all the little things. I feel like I can mention the little things that we design with the product, and it seems insignificant, but I'll tell you, if you take like 1,000 of these little things and feedback you get and put it into the product, it really makes a transformation happen, and that's what we've done. And we were awarded last year actually on the Quick Connect, which was a huge moment for us. Harnessing, so you can kind of see from the picture. It used to be kind of chaotic. Like you had Modbus daisy chain as one circuit, you had power as another circuit, and then you had 2 different colored tubes. I'm sure some of you have seen our old product. we really just said, this is way too complicated. We're just going to do one umbilical cord, right? So you just have power, controls, and one pressure tube so that we get our reference at the cone. And this runs straight back to the quick connect. And it's a much more predictable path, right? Because you're trying to automate and write code. So by making it this simple, it opened the door to have a very well-written code base that allowed us to completely predict the routes so that you no longer actually have to fasten with a drill to the wall. You can just assemble the harnesses right on the wall. Again, we say simply efficient. We just try to make it as simple as humanly possible. You know, our joke is like your mom can install our product. Like the goal is to make it super easy. And maybe that'll be a good marketing piece later. The wall assembly, you'll see more details, but it's a cool design. It's an interlocking design. You know, a lot of our obsession over the kit was inspired by retrofit. So when you replace an existing fan, so keep that in mind as you learn more from Q-PAC, that the bulk of our innovation stemmed from getting an old, you know, massive DWDI fan cut out of a hole and carrying ours like a ship in a bottle. So a lot of the inspiration came from that. So like, for instance, the number of parts, right? Like what are the fewest number of parts possible to build the structure so that you have less chance of misplacing a component, right? A lot of these installs happen at 1 a.m. Like they've done demo from 5 p.m. to 10 p.m. and now they're getting started with the install. We don't want contractors to have too many pieces to juggle. So things like that, like minimal number of screws. I'm sure, you know, some of the Mass team, I know Jerry from Mass, one day out on this shop driving screws and your entire shoulder is killed. Now we're scrawny, but either way, what I'm saying is, if we can reduce the screw count, the number of times you press the drill, if we can reduce it down to like a fifth of anything else you've ever done, I can promise you that it actually makes a difference, huge difference. So this is kind of what the kit would look like from a rendering perspective. The fans ship too high, the control panel ships separate, and then the bulkhead wall. And inside this box, the cardboard box has everything that you need. It has all the bolts, the screws, the harnesses, all the zip ties, the instructions. There's some stats from 2019. So 2019 is when we split the companies again. So these are just some numbers. Square footage has stayed the same. And really, we think it's not like we're like on top of each other in there. So we think we can get a lot out of the building. But yeah, we've grown a lot. Here's just real quick. Well, these are a few I selected. I handpicked some projects. So I don't have precise stats, but we're in a ton of colleges, a ton of high schools, elementary schools, middle schools, airports, skyrise office buildings in most major cities. Here's a few that I selected. We got the Orlando International Airport. Chicago Public Schools has been a big one. There's fans at Chicago Public Schools that are from 1876, which just is insane. If you've never seen a fan that was powered off of steam when it was installed, it's unreal. I intend on, hopefully, if I can work with the Turbo Systems team, to get one of the actual 1876 fans and put it like in our headquarters. We might not be able to fit it here, but maybe at the next facility, because it's just fascinating to see how this stuff was crafted. This is huge too. Honestly, until 2 days ago, I had never Googled. I knew that it was called the Inglewood Stadium. It's in LA. I had no idea what it looked like. So I don't really watch sports, but dome is amazing. And I'm pretty sure that if you're inside that dome, every cubic foot of air is provided by us. So the Met Museum, really interesting building. I've been there a couple of times for work. I need to go there as an actual tourist, but that's also a huge one. And then the U.S. Steel Tower, really interesting building from an architectural perspective. It's got exposed steel on the outside. So, and Nationwide, everyone knows Nationwide. So their entire headquarters is Q-PAC. I learned a lot. They're one of the more advanced facility management teams I've ever met in my entire career. It's cool to see a team so relentless about their energy consumption. Like, you can learn a lot just by listening to what they're looking to do with their building. So anyway, those are the ones I picked. We've got countless others to show you. Our target markets, existing air handlers, obviously, when you need to replace an old fan. Lots of these air handlers are hard to get to. I've seen some wild placement of air handlers inside of a building that you cannot get to, and our kit really snakes its way through all of the little man doors to get there. New air handlers. Most people probably don't realize, but a tremendous amount of our business, anywhere around, I would imagine 3/4 of our kits that leave this loading dock, they're going into brand new air handlers that have never been turned on. So huge business for us. And then obviously built up air handlers when you're at the big stuff. Verticals, just to clarify where our focus is at for everybody. We're primarily focused in commercial office spaces, hospitals, any education facility, K through 12 or higher. And then we also get into government, jails, airports, courthouses, sporting arenas, like I showed you, and some manufacturing, not a ton. But the general theme here is the product is designed for comfort cooled systems. If you're cooling people for comfort or heating people for comfort, that we're in the comfort cooling space. So if that wasn't clear. All right, tomorrow. Now on to the next chapter. So this is really the core. Yeah, I've been spending a lot of time this year thinking about how we got here and what's the future look like. I don't quite have it completely figured out, but there's a real central core that I'm seeing. And then I'd like to, I think everyone would get it. The Quick Connect box is just a box, but really what we've built is a single point fan array. Single point gets thrown out a lot in the industry because people want something to be single point, but sometimes that concept, that term is very loose and it actually isn't as simple or singular as people want it to be, but we're trying to really make it single. So there's a little bit about this that we're doing right now with the single point fan array, but there's some things coming in the future. So we're starting to see this as a standalone product, right? So just having what you see on the screen here, right? So every system that we've shipped to this point has been paired with a control panel, kind of like as a pairing where you get the control panel on the outside of the air handler. You can mount it wherever you want. You can put it either right on the air handler or adjacent. But we're seeing a big opportunity for a lot of applications where they really don't need all of that. They want something even more simple and lean. And that's where we're putting a lot of focus on our single point fan array. It's a single point of power and controls. It's a drop-in replacement for any large fan. So you can see this as just a direct replacement for a large Hunnam fan or DWGI fan, really any fan that would go into a commercial air handler. Now, one of the key differences comparing to a large commercial fan is typically you have to pair that fan with a VFD. So ours inherently, you just wire straight to the Quick Connect here with your power and controls and give it a 0 to 10 input and you have variable speed. Obviously, we're leveraging the technology from EC motors, much more efficient than the AC. Reliability. So when it comes to redundancy, N+1, let's add another fan just in case it fails. We have the capacity, right? There's a lot of concepts and theories and engineering terms and practices that get thrown out. And if you really boil it down, what do people want, right? Like, why do we mention N+1? Like as a N+1, it's like algebra, right? Like, well, why are we bringing this up? But it's because we want something that's more reliable. But the truth is if you just had a fan that didn't fail, was more reliable, you could trust that it's always going to be on and it'll let you know when it's having issues. That's really what people want. They don't necessarily want the mental cognitive load of having to worry about how many of something there are. The truth is, from my testing and just experimenting, and I'm going to probably talk to many of you to get your feedback. Even the word array kind of comes with some weight. Like when you mention array, people make lots of assumptions, right? Just from that one word, the weight of it, the heaviness of how many things are in this array and how much wiring is that going to take. And like, you'll have instances where someone will request for, a price from a contractor, and just the difference between saying fan, like a single item, or an array, they may not even bother quoting it. Like we see this kind of activity in the market. It's kind of interesting. So with that said, we're treating this as just a single, we're calling it a single point fan array, but we treat it at Q-PAC as a single fan. And we intend on getting it much better, accurate, amplitude rated performance, like putting these things in a lab and really studying it right now. We kind of do we've done some testing, but we do a little bit of interpolation, assumptions, just like any application engineer would do, right? We're making assumptions on what these 5 might do interacting with each other. And we'd like to go further and actually know the true performance of the set of EC bands. And then all the other benefits that I told you, from a lightweight, short in footprint, incredibly easy to assemble. Like I said, we used to call this wiring. This used to be wiring for years. This is not wiring. Those are conductors, like those are passing electricity, but we are not wiring these. This is all plug and play, completely general assembly. The same person that's driving this screw on the bulkhead could do the full assembly themselves. The only wiring that needs to be worried about is right here at the quick connect. So this is basically our motor, if you will. So if you really think about it, single point, all fans that I used to install back when I was building air handlers, most fans were a single point. That's all it was. So if you cross this out, it's really a fan, and we think it's smart. So that's kind of where we're at right now. And I'll kind of demonstrate right here. So like this, just to help you understand how we treat this at Q-PAC, this is a really big system. So, right, it's a big array, but we treat these as just individual fans. And a lot of people that aren't aware of how our product works, and we'll do a better job. Like Kurt said, we're finding that we need to do a better job educating. This image could be very overwhelming if you're an electrical contractor. If you're not aware of how simple the system is, you might think there's a huge scope here, but really it's just 3 large horsepower fans. So this would be like a smart fan array. So I hope that kind of clarifies it. Like I said, I think it's hard to illustrate the future. I'm learning, but in general, we want to make it simple as humanly possible. And so another update coming, looking forward to the future. Clips. We've been working on this a while. We probably burned some people out on how long it's been, but we're working on a B2. I won't spend a ton of time here, but it's going to be restructured projects. Just trying to make ease of use again, faster performance. Yeah. And expanding the building. Like I said, we think we can do a lot in this facility, but we're working with an engineer and a general contractor to expand. That's all I've got. Yeah. Thanks.